So today we're going to talk about what happens to blood clots when they are no longer needed. And so in the process, it begins within the first 30 minutes after this happens, which is clot retraction. The clot begins to constrict the actual fiber network, and the clot begins to pull the elements together into a tighter bundle.
And then platelet-derived growth factors secreted by the platelets and endothelial cells will stimulate mitosis of the fibroblasts and the smooth muscles, which will cause them to grow quicker and repair damaged vessels. We'll see that in this example. Here's a clot, and here's the forming of the clot, and then over that, the blood vessel will reform itself.
Next we have fibrinolysis, the dissolving of the clot. There are different blood factors. Factor 12 that speeds up the formation of the number of different enzymes which dissolve the clot by breaking the fibrin, converts plasmogen into plasmin, which breaks up the clot. We can see here the cycle in which it goes.
And after the healing process, that is what happens to the clot after the healing process has begun.
So basically, a clot isn't formed when there's no tear because of a bunch of factors. The first is platelet repulsion, which means the endothelium within the blood vessel has basically a non-stick surface, and it doesn't allow the platelets to adhere to it. It's only when the tear, as you see here, when there's a tear, the platelets can start to adhere to the edge, and they'll eventually form this clot.
And the natural flow of the blood keeps them from clumping together. Also, the other contents, such as protein and plasma of the blood, keeps them from clumping together.
The first anticoagulant is secreted by the liver and is called antithrobin. This inhibits throbin action on fibrogen. The second is heparin. That is secreted by white blood cells and serves as the same function as the first one.
You've already said